Welcome, welcome, one and all. I am a little bit early, so I will wait for everyone to jump in. All right. We'll just wait for everyone to mosey on in. Come on in, everybody. Have a seat. We're going to start a little bit early because this is going to be a bit of a project. I want to give everybody the opportunity to see this. So, don't worry when I do get to the test part. I'm topping off batteries right now. Everything came in, the gear assembly, so that's all ready to go. My carbon fiber rods. We are good to go to spin this baby up. So just waiting for people to get. I just hope that the Lord above, there's more than one person that shows up. I'm telling you. Hold on, I'm gonna get my gray cord, my charging cord, make sure the phone stays charged. I'll be right back. Let everybody come on in. Have a seat. All right. I swear if nobody shows up, I ain't doing it. Y'all don't show up, then I'll just videotape the damn thing. Videotape. That's how old I am. Come on now. I know we got more interested parties than that. There's a little bit more light on that side. That's a little bit better. All right. I'm gonna wait for people to mosey on in. I said I wasn't gonna start till 8. I'm gonna give people time to do that, or to get here. I'm just getting things set up. If you have any questions about what it is we are going to do, besides what wasn't in the description, feel free to ask. Welcome, 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 everyone. Come in, have a seat, get comfortable. Grab your popcorn. It's going to be interesting. Especially if the fan explodes at 30,000 RPMs. But that's what we're here for. We're here to find out tonight. So y'all got 10 minutes. I said I was going to start at 8 p.m. Pacific Standard Time. Hopefully I said that correctly. And then we are going to get started on the assembly. So you can see how I'm going to put this thing together, how it's going to go into that ductwork over there. And then we're going to strap this baby down and pray. Because, man, it's going to get interesting. Come on in, everybody. I want to see those numbers up. I want to see those hearts, those celebrations. This is the time right here. This is a whole new gear system. We're going to see if it survives. Now remember, we do have a goal for this. If it fails, we do it again. No big deal. Just print stuff up again. So, with that said, all of you that are here now, I'm going to assemble this system in front of you. It's not going to take very long. Shouldn't take very long. We're going to place it within the ductwork. Run a couple bolts into the ductwork. Then I have to put the chains on this thing. So if I don't put the chains on this thing, it's going to take off. It's going to take off big time. Oh my gosh. Okay, come on. One moment, I have to keep my straps ready. Anybody makes any jokes right now? You're thinking the same thing I am. Alright. Topping off my final battery here. Then I'm going to top off my BEC bat, which don't take a few minutes because none of it's really drained. And then we are going to assemble everything right here live in front of you. I'm going to put it in there, strap it down, power it up with two 2200 milliamp 70C 22.2 volt LiPos for a total of 48 volts, spinning a 6374 190 kilovolts flip sky motor through a 4-to-1 planetary gearbox. This was fun to design. It really was. Waiting on the carbon fiber rods wasn't. Trust me, I'm gonna need chains. It's plastic. I won't need chains. Well, I have dealt with fans like this before that I have built, and trust me, I'm chaining this mother down. But welcome. Welcome, welcome. I know what's going to happen. We got 6 minutes till 8, and then we'll get everything started, putting everything together, showing you how it's all going to go. And then we're going to put it in there and get started. The idea was I do the live where I assemble the fan. A lot of people have followed me so far on the actual build. So they've seen the previous versions of this fan. Trust me, it needs chains. Now, what I expect to happen is either a gear failure in the planetary system, something jams up, something breaks, and if that happens, that's totally fine. That's what all this is for, is testing. So basically what we're going for is the older planetary gear system with printed gears. I could not get above half throttle. Not even close. Almost, but not even close. So it did about, I know the PLA version of this fan handled 15 to 20,000 RPMs fairly easily. The projected thrust output on this fan is 55 pounds. Now, that's a lot of force to deal with. Yes, I am going to eventually print this fan out of alloy. I'm going to get I'm picking up one of those pocket NCs, and I designed the actual hub itself to be, instead of just a single printed fan, I designed the hub so we could basically mill the hub, mill the blades, balance everything out, lock everything together. That's one battery. Last one for the top off. This is just to ensure we have power. Alright, here's our packs. GERR power. Okay. Well, I'll get to the questions here in a second. The motor is 48 volts. We We are running a 150 amp 48 volt ESC. That's going to be our main power. I have a 5 amp BEC separate because that ESC doesn't come with a BEC. Oh, this is a standard Boeing high pass 22 blade fan. Just shrunk down to 170 millimeters. Pratt & Whitney. That's what the blade's modeled after. Four people, huh? Should have made a video and got more views. 6 over here. I don't know if this thing's accurate. Well, maybe it is. Maybe it is. But again, I did say 8 p.m., so I'm letting people mosey on in. Okay, I figured that one was full. Okay, that out of the way. All right, we have our power for the BEC. That's all set. Okay. Be patient, everyone. Be patient. The goal tonight is just to test this new planetary gear system. This was a front drive system, and the reason why I did this originally in front drive was for the purpose of testing and making sure I could swap out gearboxes and so on and so forth without any problems. Then I ran across the issue of 3D printing it in metal, laser sinturing, which basically had too much of a plus or minus offset for these teeth to be anywhere near effective and have a good fit. It needed to be CNC'd and not printed. Realistically, when you're doing your designs, you know what machines you're working with, so you know the tolerances of those machines. When you can't afford one of those machines and you have to order the print from a person who does printing, like PCBWay in this instance, I wanted to CNC it, but I guess they didn't have an option for it with this. For whatever reason, they said they couldn't CNC it. Maybe they didn't have sharp enough tools. I don't know. So they suggested that I 3D print it. And they gave me the offset. And I'm like, you're telling me it's plus or minus 0.3? You want me to go off of those specs? That's like a 6. That's a 0.6 margin I've got to worry about when it gets here. And it took a month to get here. So, I mean, realistically, you know, what are you going to do? I could get it to half throttle on these gears printed out of nylon 6. But they kept stripping. So I just decided to go with something a little bit more robust. Bigger gears. Very fresh, so it's going to be fun to turn, you know. Not hard to turn, but you're definitely going to hear it for a little while until I wear them in. So, all right. 'Tis 2 minutes after 8. We have some people here. So what we're going to do is we're going to get started. I'm going to move this over here a little bit. The fan itself is held in to the stator casing by the bearing and a bearing cap that I had put on the reverse side of it so that the fan cannot move. I also have these 3mm screws on a TPU, AMS TPU shaft for dampening. It's like the hardest galvanized TPU rubber I've ever used before. So it may or may not work. Hell, it may fly apart. You might see the fan go flying at the phone, who knows? But the point is, we're here to test things, so that's what we're gonna do. And the first thing we're gonna do is we're going to fit the gearbox on like so. And we're gonna run the screws in, some of them, just to get things seated up. Takes a little bit of time to assemble. But that was the idea. I wanted you guys to kind of see it. And if I have any issues or something breaks, I'm not worried about it. That's the whole process of this, is learning from my engineering mistakes. Which is how we got to this point to begin with. With the rear drive system and the bigger gears. Because the smaller gears, they work great, but not printed in plastic and definitely not laser centering, because you can't guarantee a good fit that way. Unless we're getting plus or minus 3.3, that's a huge difference. Wouldn't you agree? And plus or minus 0.3 is like a lot to expect for a customer to accept as far as a finished product goes. I mean, hey, my bad for just taking it. I was like, okay, maybe I'll get lucky. What I need is a CNC. FDM will have to do for now. Everything's threaded into the casing. I mean, everything could go really smoothly. It feels like it's going to. You can hear the gears, but you can see it's turning that fan 4 to 1. So that's what we want. Target RPMs for this one at max throttle is 32,000 RPMs. I probably will not go that far. You need an electric hand driver, but when you're doing plastics, you're gonna be able to feel it, so don't want to over torque. Ideally, I would machine all of this, but sending that out to be done, I don't know. It's taken a huge risk because even, well, if I send it out to be CNC'd, I can imagine the tolerances would be okay. It's just that 3D printing, that laser centering, that was the issue in the beginning, which sent me back to the drawing board on the gearbox and just said, you know what, let's go simple. Let's go too simple. All right, now the fun part. Keep you right about there, and we will I knew this was going to be a bit of an issue getting into place. Okay. Okay. All right. Too much gap we got here. I think I'm bottoming out on the yeah, I'm bottoming out on something. Probably that sun gear. No, it wouldn't go all the way through like that. I still got room. Let's find out what's up. Yeah. You know, we're getting there. All right. Let's do this. Where is... That's for my 2 mil. Oh, I think I had it. Right. Yeah. Okay, there we are. Okay. Should give us what we're looking for. Yeah. Okay. We'll space it. So I think what's happening is the center shaft is, it's either indexing with the, you know, because it's not that long of a shaft. So it shouldn't be, I'm gonna leave it indexed, but loosen it a little so I can spin it. Yeah, I mean, it shouldn't be. I need a little bit more persuasion. Get her seated. Okay. Be close enough. So let's tighten this up. All right. So if we have failures, that's totally fine. What this is all about. Not failing, but testing. Hey, how you doing? Glad you could be here. Hope more stop by. You would think that they would. That's going to be interesting. That is definitely going to be interesting. All right. Okay. PXD, you have arrived. Alrighty. We're getting things set up and assembled. We already verified that it's spinning the motor, or spinning the blades, I should say. Either way, it's going to be interesting. Wish I had some music I could play for you guys, but you know, YouTube and copyrights. You know how they get. Honestly, doing a vertical live, I couldn't tell you how I play music anyway without getting in trouble. Once we move closer to the fan's rigging station, not rigging station, the place where I mount it, before it spins up, we'll get the camera closer so you guys can see everything going down. Do not worry about that. Oh, this is gonna be nuts. It's gonna be so nuts. All right. Let me make some room here. Okay. I will get the camera closer. Yeah, I can't wait either. This is going to be, it's either going to run really well or it's going to run for a little bit and then like stop working. But this is what this whole thing is for. You've seen me do spin ups before, so you know. First thing I gotta do is get this on. The motor's a little heavy. And run. Let's do it over here. The motor's definitely heavy. So like I said before, this is a live test, so we expect success and or failure, and we will accept both for the purpose of data collection. Let's get a U pin down here. That's held together, so let's go ahead and move it this way. Make it a little easier. Yes, I'm gonna put, see these over here? These nuts. Those are going on, so don't worry. This ducting is strictly for testing, so. You can pretty much use whatever ductwork you want to, or just drop the entire assembly into a plane of your choosing. A kingdom for an electric hand driver. At least until you get down to the bottom, where you want to feel it. Squeaky, squeaky. No, it's not going to be airtight. Buck, how's it going? It's going to be a very exciting and or disappointing yet epic adventure tonight. We all hope. Fingers are crossed. Need one more under it. Okay. Right here, run some screws down. Put the nuts on. That'll hold her in place, right? And then we will tighten her up. Okay. Now on the inside of this fan, there is some stator rectification I wanted to put in there closer to the back of the motor to not only rectify flow, but to also keep it pinned down inside the ductwork. Technically, if you're doing this for one of your projects and you're just dropping the motor assembly into the fan, or the motor assembly into an aircraft, you wouldn't need this part. But this part is necessary for testing. So she's going to give us what we want today, or she isn't. Either way, it's going to be fun. The carbon fiber rods for the planetary gear system came in today. So I cut those, got them ready. I'm going to put into place through the bearing ports. Okay. Now, let me get this thing strapped down real quick. Good Lord, that's what the chains are for. Okay. Okay. Oh, hold on. My chains are tangled. I know you probably think, well, does it really need chains? And you know what? It might not. It's just realistically for safety, so this thing doesn't come flying off. But I've done this before, so yeah. The chains weren't just something I said, oh, let's put this on there. They'll look cool. No, they have a purpose. Extend the rope, extend the chains onto the hook. Okay, and the ropes. The rope is good, it just needs to be tightened up a little. Well, I think the chains will hold it. We'll see. Okay. Oh man. Okay. Let's get this camera moved, huh? Alright, what I'm going to try and do is get it to where you can see, well, first off, please, for the love of God, stay on there, okay? Alright. Can't forget our lights, right? Be the most entertaining part of the show. I think it was red, yellow. I can't remember. We'll know when the fan starts spinning backwards. RX power. Yes, we have RX power. Okay. I think it wants me to calibrate. We'll find out now. All right, fingers crossed. What we're gonna try and do first, we're gonna see, I may have to hot glue that down there. But we're just gonna see how which direction. Okay, she's blowing, so we gotta turn it around. I knew I was gonna hear those gears first. Really? You're gonna make me calibrate it every time? Alright. Oh, good Lord. Okay. Alright. Now, please keep in mind, this is a test. If the gears fail, if anything fails, then I know where to go from here. Oh my goodness. Okay. I'm a bit nervous on this one, man. All right, we're gonna run it for a little bit. I'm gonna get the hell out of the way. We're gonna run it and see. First off, hold on. Let me hit it with a little Interflon. If I can. No, I already did that. Sorry. Never mind. All right. Fingers crossed. So far, so good. That was barely quarter throttle. Okay. I'm getting my ass behind something. All right. That is scaring the living shit out of me. I'll tell you that right now. Woo! It's blowing stuff everywhere, though. These chains. Okay. We're going to hot glue this. I just want to make sure the fan does not move off the stand. It's trying to right now. So, we're definitely going to hot glue this. Real quick, like. Because that'll come off easy enough when I need it to. So give me a minute. Doesn't look like anything froze up. Let's make sure. Okay, everything's still free spinning. I'm gonna hot glue this, make sure nothing moves. And then we're gonna send it till that thing does something we don't expect it to do. Something's gonna go. I guarantee it. Let me get the. I gotta get the glue gun. Give me 1 second. It's taking a minute to heat up. Oh my gosh, that is a nervous. That's a nervous thing to do right there. That's scary as hell. So all that sound you're hearing is that planetary gear system, which. Watch the back of my big head, right? Watch. Okay. Okay. Holy crap. All right, guys, look. This is what's going to happen, okay? I'm going to glue this case down just so it doesn't rotate like it's been doing. And then we're going to send it. And then what's going to happen is it's either going to work perfectly or the fan's going to come flying off or the fan's going to explode. Either way, I'm going to the other side of the garage for this one because it is scaring the crap out of me. But I'm telling you, the gears are working. I mean... But you can see how that... A little bit of a wobble with that TPU, AMS TPU shaft there. But I think it probably would have snapped if I hadn't. But that index rod goes all the way through to the planetary. So, yeah, let it wobble because whatever happens... It's going to be a fun one. And if this explodes, we already know we're going to have to go to CNC as far as that's concerned. So, Oh my gosh. All right, hold on, we're checking the glue gun. Need a bit more time on the glue gun. Okay. Catch my breath. Take a drag. Take a hit off of something. Holy crap. I can already see what I'm going to have to do in the future is put a bearing on here. Well, you know, if it's out of alloy, it's not going to matter one way or the other. It's going to work. It'll be a lot more rigid, that's for sure. But when you're using PETG for the whole thing, you know, you kind of have to work with what you got. All right. So this is for the purposes of just helping me feel better about the whole damn thing. So that glued down. I don't care how bad the casing looks because the casing's disposable. Okay. There. A little bit back here. Okay. All right, so they'll dry up for a little bit. Oh man, this is probably the scariest spin up I've ever done. I'm gonna tell you that right now. No smoke, but that fan may come off of there. See, when it was driven from the front, it was spinning this directly. That gave me the ability to really stabilize the fan. Now, the only stabilization it has is this index rod, which goes through to the main bearing, the planetary, and then that's it. So there's no stabilization from moving up and down in that bearing housing. Granted, I did use TPU from the AMS because it's very rigid, because I needed a dampener for any vibration. I think at a high enough RPM it'll straighten out. What do you think? We're waiting for the hot glue to kind of turn that color we're expecting, and then I will proceed with my heart attack. Either way, it's gonna be fun. All right. I do want to tighten this rope up though. A little bit. Mainly because I need it to be the same tension as the chains. So that's easy enough to do. This will just kind of make me feel better about the whole thing. Okay. Because I want the same tension on the carriage here as I do on the fan itself. It makes me feel a little bit better. Okay. Okay, boys. ladies and gents, I think this is going to be it right here. All right, here we go. Woo! What was that? Something hit me over here. Wow! What went? What went? What went? What went? Oh! I lost the motor mount. That's okay. I can reprint that. Whew. No, the cord didn't break. The motor mount did. Not the whole mount, just sort of half of it. Yeah. Oh, it didn't unplug the motor in the process. Well. Oh, because the motor twisted. Yeah. Top half of the motor mount. Here, I'll show you. So, definitely going to have to... It got a lot faster than the other one did, that's for sure. Okay, let's unplug the power. It's freaking me out a little bit. So motor mount, for sure. I know exactly how I'm going to beef that up. Whew. Yeah, I'll show you here in a second. We're going to take it apart. You remember these legs that went down into the casing, right? Well, it was more modified off of my original design. So what we're going to do is we're going to add some strength to those exterior legs, and then we're going to take a look at the gears right now and see how those turned out. Can I make this faster? Where's my drill? Ah, there she be. Now you know why I was like on the other side of the room. Yeah, the motor does need to be, head needs to be locked in place for sure. I'm going to leave that other part of the case kind of where it is. Got a little over half throttle. Definitely will have to go over the live footage to see how far over half throttle. It's under there. Okay. I'm gonna find it. It's not like I'm gonna run it again. So the planetary gears Okay, here we go. Hold on. Yeah, we're definitely pulling this apart. The gears held all right. You know, still spinning the fan. It's just this mount. So knowing that, I'm going to redesign it and get it to a better state. So that it can function better. But yeah, everything's still attached. It's still spinning the fan. I expected the fan to go. I didn't expect this to go. Honestly, I didn't expect that. That's wild. I'm actually kind of excited because my main system is still in one piece. It's just this mount I gotta redo. Oh, so we know we're making it. And from what I could tell, the planetaries, they only backed out when this gave way. So I imagine if this was more rigid. But again, designing stuff for CNC and then using FDM, you know. So yeah, I'm definitely gonna fix that. Faux show. But I'm surprised that's all that went. We'll call it my unintentional safety breakaway points for this spin-up. See? Everything's accidentally planned for a reason. All right. Gather up all the nuts and bolts here. That was wild. That was too wild. I didn't even get to look at it. I was over there behind the chair. I was like, I'm not getting anywhere near this damn thing. And I made it. Now, realistically, when it comes down to finally having a system that pulled my gears out. Hey, at least they're wearing in. Did it lose any bearings? Oh, there's some right here. Okay, yeah. So you can kind of see how I did this with carbon fiber rod. Wait, did I lose any? I think I did. Oh, maybe one out of the bottom here. No, because that one was here. Okay. So you can see, yeah, it was out of the top of these sides. So that's what happened. These two go into the top here. Planetary gears, I mean, they held up. They definitely held up. I will give them that. Better than I thought. Way better than I thought it would. So, what have we learned? Everyone's like, what have we learned? Oh, wow. Whoo. Yeah, everything survived, man. The gears survived. We have crossed a line now. Now I just need to make that mount a little bit more robust. Take into consideration the break points and the stress points that it had on it that made it actually fail. And print it up and do it again. I mean, that's a success. I know everyone's like, no, it broke. I'm like, no, it didn't break. It just failed in one spot. Well, a few spots. The motor mount, if you're going to get technical. But yeah, it worked. It actually worked. So you go there. Okay. You go here. Like a little puzzle. You go here. Okay. Yeah. Wait, that's probably not where that one goes. Don't you hate it when you do that? There. Now all that's back to normal. So the only thing I need to do is print this. This mount right here. Let's pull this collet off here because that goes right into there. So it's just the mount. That's all I lost. That was the mount. And we still have a working fan. Hell of a success tonight. I did get above half throttle. Again, I didn't get to watch it on the video because this was some scary crap right here. But it worked. That is so good. That is so freaking awesome. So we're gonna go back and do this right here. Redo the mount. Now that I know where its weak points are, try to basically optimize it for the FDM process. Because I think it would have been fine had it been a CNC'd aluminum mount. Or even a printed one if it was accurate enough. So, well, you see, SB, that's the plan. That's why I'm trying to save up for that pocket NC, because it's the only really affordable solution, at least in my price range, which isn't even my price range at this point because it's too expensive. It's like 11 grand. I don't have that. I'm on vet benefits. So, yeah, I am very, very, very happy about the outcome of that. We didn't lose the fan. We didn't lose the planetaries. We didn't lose the collet. We didn't lose anything except the flimsy-ass motor mount. So, yeah. But if anyone feels like buying me, like 10,000, 11,000 coffees on my Buy Me a Coffee link, or 11,000 if you join Patreon, then I'll go buy the Pocket NC. and then I'll share it with everybody. And you're like, hey, CNC this for me. Everybody pays $2-3. Hell, I'd have that thing up and running and get a good fan going. And if you guys needed work, I would be your 3D printing alloy CNC solution instead of China. China. Used to be Russia. Now it's China. All right. That was awesome, man. That was totally awesome. And the whole main system still in one piece. Nice. All pushed by a electric skateboard motor. This one's a 190 kV. 6374 190 kV from Flip Sky. It's a good motor, has tons of torque. I figure if it can move a human, it's going to do good on a 4-to-1 gear ratio. So yes, success tonight, guys, success. Oh, that's a good feeling. Knowing that you don't have to print an entire fan again. Yeah. Oh man, I'm telling you, that was scary. That was scary, but it worked. I'm definitely going over the footage and clipping that that main spin up, and then watching where it actually broke, and see exactly what happened, because that was insane. I mean, it was getting ready. I mean, it was pulling. It was pulling hard. I mean, whew. I'm telling you right now that ductwork is a test rig. So if I screw that up, totally fine with that. It's this main system right here that I put together. These carbon fiber rods came in today. I cut them, fit them, slapped them in there. Didn't even do any last minute measurements or checks. Just threw it together on camera, ran the thing. That was the whole point. Now we know where the failure point is. So now that we know where our failure point is, I'm going to go fix it. I know where it broke. I know where the reinforcements should be. And I think I need to drill out a little bit of this collet here, or ream it out a little bit, so that shaft goes farther down in there. Because I had plenty of room to push that shaft all the way in. It just didn't want to go, giggity. Because it was a little tight against the walls. Giggity. I had to say it. Sorry. So, that being said, that's all we lost. I'm so happy. You have no idea. Most of you do have some idea of how much of a success this actually is. Screw the motor mount. It'll take me an hour to print it after I redo it. But everybody who is watching, that has watched me from the beginning, knows how much of a success this is right now. And my wife is watching. She's proud of me, and if that's all I take away from it, that's all I need. Oh man, that was awesome, guys. That was awesome. Oh. Yeah, if you are new here, please subscribe to my channel. It's going to help me greatly. It's going to help. I hate the cliche. It's going to help the algorithm, because I don't know what the hell the algorithm is doing. All I know is if you subscribe and then share it with other people and they subscribe, that's how it works. You guys are not algorithms. You guys are people. So tell your people. That's what we're talking about. And I thank God Almighty that I didn't catch one of these blades in the chest. The last time when Stubby V1 blew up, I was holding it. And if it wasn't for that external fan casing that I have right here, man, I would have caught those to the face. Because that was dumb. I should have never been holding that thing. Whew. Man, I don't drink, but if I did, I would need one right now. I'll tell you that. Yeah, I know you have been, PXT. He's like, this dude's going to blow himself up. Watch. Or he's going to be like, he's going to do a short or a live from the ER where he's got PLA blades sticking out all over his face. You know, I assume what he expects would happen to me. Now, the debate, because there was a little bit of wobble in that blade. There was a little bit of wobble in that blade, but it was dampened by that let me point this out to you, okay? Let me show you. I'll show you. I've got one in the case right here. Hold on. Sorry. Okay. This piece right here holds the fan into the stator casing through the bearing, and then into the sun gear of the planetary gear. So I printed this. This is a central part. This is a very important part in keeping that fan where it is. I printed this out of TPU for the AMS from Bamboo Lab. TPU. That's what's in there. And it's rigid enough to where I don't have to worry about it breaking. It's got the same flexibility as the PETG it does, but it has a layer bonding that is beyond anything I have used. And with the rigidity of that TPU, designed specifically for the AMS, not standard TPU, okay, we all know that wasn't going to work. That TPU is what dampened that wobble you saw in the blade, or it was the cause of it. Either way, it held together. It didn't move. And this fan, this index, it is friction fit in there. Oh, that was wild. That was too wild. Oh, I got another bearing here. I could probably put that in there. Okay, well, we'll get to that. Right now, I'm going to need tobacco. And calm down a little bit. I'm telling you right now, that I cannot believe that TPU drive shaft held like it did. And in the PETG, motor mount broke. Oh, the irony. Waiting for the adrenaline to wear off. Oh my goodness. That was cool. You guys got to see it. I didn't. I was over there. I was over there behind a metal table, just in case it exploded. Oh. I am happy with the results, though, guys. I really am. Very happy with the results. Hold on, I got a little bit of extra oil in here. I gotta clean it. We're gonna use this casing again. And I'm gonna reprint the fan, or not the fan, but the motor mount. And it shot that stuff everywhere. Wow. Wow. Okay. Definitely faster than it's ever spun before. I can tell you that much. Man, thanks, man. I'm glad you guys are proud. I'm glad you enjoyed it. Wait till I get it up to full throttle. That was like 2 ticks, maybe 3 over half. Almost, no, I don't want to say 3/4, because 3/4, it would have really gone up. But man, it was pushing some air, because I have 2 Huskies, and you can see it raining hair down in here. I didn't even know it was in here. So the Huskies made their appearance in a sense. Oh, good Lord. That's like riding a roller coaster for the first time, I'm telling you. Wow. And just the motor mount. That, I am so freaking happy about that. I've never been happier with something broke in my life. It was just that. Everything else is cherry. Look. Oh my gosh. And I got a chance to wear the gears in a little bit. So on the next run, it's going to be even smoother. But you're right. Our next step is to try and figure out how we're going to get a CNC in here, a desktop CNC that is accurate enough to where we can do this out of alloy. That is the main goal. Because once this turbine is done in alloy, that's when we introduce the low pressure turbine system that will feed into an aperture. The aperture actually won't be there, because this is actually going to feed directly into an afterburner, which will be alloyed out of this stuff. That will go into the afterburner. We'll have a longer tube, obviously, so on and so forth. Anyway, the point is afterburner. This was the front drive system. Let me show you something. This is why the switch was such a success today. That's where the motor sat before. And it was for the purpose of testing, so I could put the gearbox in and out of this system here and test it without having to take it out of this every single time I wanted to check it, right? So I have another functioning fan here. It's just front drive. And it works well. The only problem is with the TPU gears, not the TPU, with the printed gears that I have, it still spins 4-to-1, just like the other one does, right? But when I tried to have it printed in metal so that I could make it last longer, because even nylon 6 stripped out on this, and I wanted a smoother engagement, which is why I designed this, I couldn't get the clamshells to close on the exterior gears because of PCB basically saying, yeah, ±3. Well, that's almost a damn millimeter. That's 4 short of a millimeter. You're going to tell me I got to work with those offsets? Can't do it. I need somebody more professional. Or I just need to CNC it. I mean, that's all there is to it. And you don't need to CNC this case. You don't need to CNC this case. You don't even need to CNC this, obviously. You just need to CNC the blade, the drive shaft. You can even 3D print this part here that engages it. It doesn't need to be CNC'd. That's PETG. It held up just fine. Those rods are friction fit in there. I didn't have to do a damn thing except tap them in. Went straight through the bearing holes. 5mm carbon fiber rods. Bought a whole pack of them. Used like that much. Ended up doing it. Packed the gears with a bunch of bearings all the way down, and then ran the carbon fiber rods straight through all the way so that they would spin that planetary. Oh, it is so beautiful. Can't believe it actually worked so well. It worked really, really well. Wow. So a little bit more design work to do to kind of finalize, especially this gearbox, because I want to encapsulate it so that any kind of lubricant we have in there, stays in there. Plus, we're going to add some aluminum fins on the CNC version all the way around, so we have heat dissipation from the passing air to cool the lubricant down on the inside. I'm also going to have, like I said, an extra set of stators, or flow rectification vanes, if you want to call them that, coming off of here and then touching the side of the casing. And then that'll be just for this run. Anytime that you want to print any kind of support for the back on the motor, it can be something that is custom. You have different rings or whatever for whatever different size exit aperture that you're using. But the wind blowing back, let's try English, the wind blowing past CNC'd, alloy gear system with fins to dissipate the heat, and it going past the motor, that's going to keep it a lot cooler than, putting it in the front. So I expected that, but wow, I'll tell you, that went a lot better than I thought. Thought I was going to wake up in the ER and do another live. But nope. And that, believe it or not, that TPU for the AMS actually held on with all that torque. Impressive stuff. You mean bands? You're talking about the fan casing around here? Is that what you're talking about, banding? The only problem that I can see, yeah, banding the blades. The only problem I can see is because of the design of this being modeled after, the Pratt & Whitney high-pass fan, 22 blade. It needs to be able to flex. This particular fan is designed to flex. If it doesn't flex, it will blow up. So banding this fan is not something that I would consider doing. Doing a different fan, something I designed for banding, I would probably do. But then you have to realize that then that has to be have some kind of bearing support between the outer casing and the fan banding itself. And in order to do that, you really want this whole thing machined out of an alloy so that it's more of a bearing on its own. It's just lubricated. And then it's going to have to be in 2 pieces so it can be bolted together around the banding to make it work. So you could, but again, you could use TPU. But the problem is But the printing temperature differences between TPU and the PETG is too great. It won't print them both at the same time. That's the only problem. So it would have to be one of those things where you print it separately and then fit them together and then CA glue them and then dynamically balance it, make sure that works. And then after that, you've got to figure out how to get it into this casing and put a bearing system in it if it's going to be plastic. So realistically, what we would do is take this file and split it, add bolt marks or bolt holes all the way around, just like at the front and back here, and band the blade CNC'd. It'd have to be banded in, you know, each part. That would be fairly difficult because not only would it have to be slotted like this blade, each section of the top would have to be slotted as well. And then once they all slot together, then it has to go into the casing, and then the front half of the casing has to be bolted on. And it all has to be out of an alloy that can handle the heat, and it would have to be lubricated and almost in direct contact. So you're talking about making this entire thing into a bearing. And that's the challenge of that. It can be done. I could model it in there in probably an hour, but in the FDM phase of this, it's not practical at this point. Now, I can, once I get the CNC, if I get a pocket NC and I start doing it on that, or I have access to a CNC where I can actually get this thing, you know, CNC'd out and it doesn't cost me more than my car to have it done, then we could go ahead and CNC everything together. You know, CNC the outer casing and everything else. For testing, I could do it and go plastic on plastic and then just use the Interflon paste, the HG1200. It would dissipate the heat for a little while, but eventually it would seize up. It would prove the concept, but it wouldn't be something you could run reliably out of any kind of plastic. So far, this has proven itself to be a very rigid fan and very rigid gear system. And that was fun. I'm telling you right now, that was fun. That was a lot of fun. Scary, but fun. So what you want to do what I need to do at this point is I'm at the stage where I will continue experimenting with the rigidity of the motor mount in FDM, but also keep in mind the design that I need for a CNC version of the mount. Now, the mount is not crucial like the gears. So something as complex as this, you would think, well, that'd be impossible to CNC that whole system. That could be printed. That could be printed. And as long as the tolerances, and I know the machine that they're going to be using, that could you could do that at a laser sintering. But I would have to make absolutely certain that the bolt holes lined up in order for the motor to fit. So that's another issue. So CNCing this mount, if someone could CNC that, I mean, yeah. Or I break the mount apart and have it to where you're CNCing each individual part, and then I'm bolting it together. And, you know, I'm leaving indexes on the pieces so that they fit together properly after being CNC'd, and then bolt them into place. Lock tight with the bolts, make sure they don't move, that kind of thing. So, yeah, I can imagine doing it that way, possibly, and CNCing it. But I would have to make sure the mount is in different parts to do so. So I think that's what I'll do, is I will design the mount with its, you know, rigidity and its strengthening. And I think those flow rectification vanes will actually give it some rigidity from the part where the part where it bolts to the housing to the part, you know, where it intersects with the gear box, and then the top of the actual motor mount. So, and since it'll sweep around, I think it'd help. I don't know. I'm gonna have to look into it and see how I want to design that. So, But it's good to know everything survived. For the one part I did not expect to fail was that mount. I thought I was going to lose either the shaft or one of the gears or one of the rods, or something was going to break in there, or the fan was going to explode. But it didn't. It didn't. It did very well. So I think that's going to do it for tonight. And I'm going to redesign that mount, get it printed. I really would love to print it in nylon 6, but anything with nylon 6 and support material is ridiculous to remove, and it does not come out well. Small parts, fine, nylon 6. But anything else, anything bigger than gears, like small gears, you have serious issues with when it comes to support material on that stuff. Now, you could switch to a different material for the interface layer, but it's going to have to be a material that's close to the printing temperature of the nylon 6, or it's going to refuse to do it. So maybe a PLA or a PETG in a nylon 6. PETG is an interface. Then I could probably do it without having such a huge mess on trying to remove supports. But then again, reprinting this in nylon 6 as is isn't something I plan on doing. I do have to make some design changes first. And when I do, then I'll reprint it. Probably solid this time. So I think I did maybe a 50% gyroidal infill. Yeah, it's gyroidal, and I think it's 50 or 25. I did 6 walls at least on the outside. As you can see, they came apart pretty quick. Not quick. It actually lasted longer than I thought. So, yeah. All right. We know what our plan is. Redesign the mount. See if we can do it in FDM with PETG or nylon 6. And see if we can get that mount to last longer in the FDM printed stage. And that might entail redesigning the mount itself altogether. But, you know, do what you got to do, right? That was a fun run. I hope you all enjoyed it. I hope that you're back for the next one. I hope I got some new subscribers and they were interested in it and they like what I'm doing. And, you know, hey, from everyone here, which is basically me and my wife, everyone here at DPC, we love you all. Be sure to subscribe. Click the bell for notifications so that you never miss any more of my madness. Y'all have a wonderful night. Love every one of you. I will see you again next time.